Hey, right now we're going to go over some trig function stuff, just a little bit more advanced, nothing too major. We're just going to go over a little bit of stuff that's a little bit different than what we were doing before, right? So this question here is right out of your textbook. So if you have that there and you know it's a little tough to read or something like that, it's just on page 266. This is number 56. Just making sure that we're using the quadratic formula on this one. And so kind of put the cart before the horse in this case. If I was starting this one and I was kind of taking a look, I might think, maybe we could just factor this because again, it's got some cosine squared stuff, some cosine stuff here. We did that before, we just factored stuff out and it's also equal to 0. Problem here is we can't quite do that because there's cosine here, but not in this spot, right? So we can't factor that out of every term, so it's not quite going to work. So in this case here, I'm going to jump right into just using the quadratic formula, right? Because it is something squared, not squared, no variable, right? In other words, the exponents are 2, 1, 0, right? That's an exact, perfect time to use the quadratic formula. You could try factoring this as well, although that might be a little bit tough too. But in here, the quadratic formula might say, well, you know, we're so used to just having something x squared plus something x and then plus something else. It doesn't matter, right? So what? So the variables change the cosine. It's okay, right? That's still just the variable. So usually we have x equals the big quadratic formula. In this case, we will have cosine of x equals the big quadratic formula, right? You guys remember? Negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And if you sang along, fantastic. And you need to sing that to yourself. There you go. So now on here, we'll just follow through that formula. We got our negative b, it's already negative 5, so negative b plus or minus the square root of b squared minus 4ac. Well, here, c is negative, so I'm just going to say, well, it would end up being a double negative anyway, so I'll make that positive 4ac. Again, I get that's negative 5, but I switched that to a positive there, so it just makes that, keeps that step clean. All over 2a, which is just 4, right? 2 times 2. And we just kind of work this out here. This stuff in here, 25, and then 4 times 2 times 5, we could work that out. That's going to be, I suppose, 10 times 4, 40 plus 25. This is really the square root of 65, correct? That's what the cosine of x is equal to. Now we just have kind of in 2 separate equations on this one, right? Is we have 2 things. We're not quite done, right? We got to do the trig part now. That was the algebra stuff. Not too bad on there. But now I want to do the trig stuff. So on here, one option that we could have is that we have the cosine of x is equal to the positive version. Here we'd have 5 plus the square root of 65 over 4, right? It's either the additive option or possibly could be the negative option. And I'm saying negative, not meaning that we'll get a negative number per se, but just that we're using the subtraction. So I call that the negative option on there. And we check those 2, right? So on here, then we got to use our calculator to come up with what is the angle from here. We'll just do the cosine inverse, figure it out, and adjust around the circle. Here we'll take again, do the cosine inverse, and adjust around the circle, find the multiple answers. So here, I would take the cosine inverse of all of this stuff, and I'm just going to plug the whole thing into my calculator all at one time, making sure we put the parentheses in the right spot. You know, if you have a calculator that nicely formats things as a fraction, fantastic. I don't. If you have an iPhone calculator, you'll want to type all this in first and then do the cosine inverse because you can't type that in all at once. So in here, that's what I'm going to do. So I'm going to hop to my calculator and go ahead and type that stuff in. Here we would put in the now I got to turn it on here first. So we type in the cosine inverse of 5 plus all that stuff in there. Let's go here, the cosine inverse, and I got to start with the parenthesis in there. I got to put that, kind of double parenthesis to make sure that we get 5 plus the square root of 65, and then close parenthesis divided by 4. So I'd want to make sure that that double parenthesis is up there so that it's counting that entire thing in the numerator and not, just taking this part divided by 4. I want both things divided by 4. Then what we do is just hit enter, and we go ahead and find the answer on there. And uh-oh, my calculator freaked out. It says domain. I can't do that. And you'd go, what? There's no possible way. And then you start freaking out, and you check your computer across the room, and oh, everything's gone, right? Well, we don't need to freak out. Don't check your computer across the room just yet, right? So on here, we don't want to do that. The reason that this one comes up with a little thing is we're going to go here, right? Sometimes you can get an error. It's okay, right? Cosine here, if we just put in the 5 plus 65 over 4, we'll get something bigger than 1, right? That's the thing. Cosine and sine also, tangent actually doesn't matter, but sine and cosine cannot be bigger than 1. So if you try to do a cosine inverse or a sine inverse of something that's bigger than 1, it's going to be impossible. Your calculator is going to say, I can't do that. That's an impossible situation, right? You think about that. That'd be like one of the legs of a right triangle being longer than the hypotenuse. That's not possible to have happen. So your calculator just says domain error. That's what that means. So in fact, actually, if you type in anything, like here, I'm just going to do the cosine inverse of anything bigger than 1, even 1.01, right? If I put that in there and try to do the cosine inverse of that, it will also tell me that you can't do that, right? So that's all that's going on in this one. So in fact, over here, what you can say is nothingness. You can't have an answer. This one cannot work out on this side over here. So we would say, oh, all done. Can't do that one, right? It's not possible to do. But over here, we can, right? We put in that cosine inverse on there. And here I'm just going to pop back in again. I'm just going to put that negative option in there. Just putting that back through. There's the negative in there. Again, putting that double parenthesis around the numerator so that makes sure to go. And now when we hit enter, we come out with 139.96 degrees, right? So that's an option on here. It says, okay, when we use this one, use our cosine inverse, 139.96 degrees. I'm just going to rounding to 2 decimal places, usually pretty good. We put that there. Now this one we do need to check for multiple options from 0 to 360. I know I didn't put that one up there. It's actually in the book. It says to go from 0 to 360 and check all the options. So in here, I would want, again, to make my picture and say, all right, where is this thing possible? 139.96 degree angle is somewhere over here, right? That's where that one is. And that's already in between 0 and 360. So I'm going to keep that one. But where else could that be possible? Again, I'm looking for where a cosine thing's negative, right? Cosine would be positive, or sorry, would be negative in this section. So I want to look at where else we could put that, right? Well, cosine's negative here. I can put a triangle in that spot. So I'm going to put one there. And then it can't be in either of these two in quadrants 1 or 4 because cosine's positive there. And so then we just go from there, right? In this case here, we would go this way. Here's our 139.96 degree angle. That's that top one. The bottom one, we could do some adjustments. We could figure out what's the reference angle, add that to 180. That's a possibility. Or what I'm going to do is just say, well, it's 360, and then remove that angle, right? Subtract that angle around. And that's got to be what is left there. So here I could do 360. And I'm going to do a little trick here. I'm just going to do that second answer, 360 minus whatever number's up there, to figure out that, oh, that's got to be about a 220.04 degree angle. So the other possibility here that our calculator will not tell us we have to think about and get that one, 220.04 degrees, is also a possibility, right? So there are 2 possible answers in this case. Sometimes you get that when you're using the quadratic formula, or even other ways. You might end up where it's not solvable. That's okay sometimes, especially if you get something that's bigger than 1 before doing the inverse. It's not going to be possible. So that's why we just say, nope, no, nothing there, and then we adjust the other thing. If we did have an answer here, we would have to adjust this answer just like we did that one. But that's using the quadratic formula on some trig equations on that one.